Hello everyone. Today I'm going to be going over what indefinite and mainly what definite integrals are. So first off, we need to know what the derivative is. So I'm sure this is review for most people. So for an example, we have f of x equals x squared plus 2. And then taking the derivative of this, we'd say f prime of x, or this d of f dx will equal, and then using the power rule, we'll take that 2 down next to the x. So we had 2x and then 2 minus 1. We just have 2x to the first, and then the constant goes to 0. So that's the derivative. Now what's an antiderivative, or what's an integral? An integral takes on the form like a weird looking S. So we have the integral, say, of our f prime of x dx. That'll equal our original function. So that's why it's called an antiderivative. And all these, this right here is an indefinite integral. Now, taking the integral of, say, the 2x dx, this would equal, and then going the opposite of the power rule. So we see that this is to the first, x to the first. We want to add 1 to that. So we'd have 2x squared. And then with that same number, we want to divide the whole thing by that exponent. So divide by 2. So our 2's will cancel out, and we're left with just that x squared. And then, since it's an indefinite integral, we'll always put a plus c for constant. So there might be some constant that's added to this equation that we can't figure out from indefinite integrals. So our plus constant, in this case, it might be plus 2, it could be plus 5, just any constant. And that's how you do an indefinite integral. Let's try another one. So what if we have integral of, say, 1/3 x cubed plus x. Then we always put dx at the end. So for this one, we can break it up into two different integrals because it's connected by addition. So I'd say it equals just the 1/3 x cubed dx plus integral of x dx. So taking the integral of this one, we want to add 1 to its exponent to get 3 plus 4. And then we also need to divide by that same exponent. So I'll put times, or I'll put divided by 4. And then plus, and then I'll go ahead and define this integral. So integral of x, it's x to the first, so I'd put x squared now. I just add 1 to the exponent, and then divide by that same exponent, so divide by 2. And then, as always, we'll put the plus c, or plus constant, at the end. So c is some constant value. So we have this whole mess. Let's clean it up a little bit to get x to the 4th over 12 plus x squared over 2 plus c. So that's what our indefinite integral is of this formula. Now, what a definite integral is, it can be almost in the same form. So say I have integral of 1 plus x minus x cubed dx, and this would be an indefinite integral. But if I say the integral from 0 to 1, that makes it a definite integral. Now, going about it the same way at first, we get that 1, so integral from 0 to 1 of 1 dx, and plus, and here I'm just breaking up the integral into 3 different parts because it's connected by addition, subtraction. So from 0 to 1 of x dx minus 0 to 1 of x cubed dx. And working these out individually, we have just say like x to the 0 or 1, so that would become x from 0 to 1. And I put these brackets around because I want to put these constraints, the 0 to 1. I want to put those constraints on the x, but after I work everything else out. So I have plus and the x to the 1, so I make that an x squared over 2 from 0 to 1, and minus x to the 4th, and then divided by 4 from 0 to 1. Now I'm going to apply these constraints. So how I do that is I'd plug in the 1 for x. I plug in the 1 and then the 0. So I do the 1 minus, and then I plug in the 0 for x. Then plus, then I do the same thing here. So I plug in the 1 for x to get 1 squared over 2. Then minus the 0 squared over 2. And then finally minus, I plug in my 1 to the 4th over 4, and then I'll go ahead and distribute my negative to the next value to make it a plus 0 to the 4th over 4. So all my zeros will cancel out, and I'd be left with 1 plus 1/2 minus 1/4. So this come out to 1 plus 1/2, 3/2, minus 1/4, which is 5/4. So this definite integral of integral from 0 to 1 of 1 plus x minus x cubed dx equals 5/4. Now, the correct notation for showing an integral or a definite integral is the integral from a to b of some function of x, like up there, dx equals the original function of b, that top constraint, minus the original function of a. So this is your definite integral. So I hope you're able to follow along, and good luck.